Hi everyone, welcome to my A-level biology lecture series. In this lesson, we will explore the respiratory quotient. At the end of this lesson, you will be able to state that the respiratory quotient is the ratio of the number of molecules of carbon dioxide produced to the number of molecules of oxygen taken in as a result of respiration, and calculate RQ value of different respiratory substrate from equation for respiration. Let's get started. Respiratory quotient is defined as the ratio of the volume of carbon dioxide produced per unit time to the volume of oxygen consumed per unit time during respiration. It is very important when you define respiratory quotient, the words that we use here per unit time must be included. Why it is so important? Because when you have a ratio, you must make sure that the duration of time is constant when we measure the volume of carbon dioxide and as well as the volume of oxygen. So that's important that we must mention here per unit time. So the formula given here, you can see that RQ equal to the volume of CO2 produced per unit time divided by the volume of O2 consumed per unit time. So what's so important to calculate respiratory quotient? So the RQ value provides information on, first, the type of respiration, whether aerobic or anaerobic respiration, as well as the respiratory substrate, the type of respiratory substrate used by the organism to carry out respiration. So generally, if the RQ value is greater than 1, so it indicates that less oxygen is consumed and more CO2 is produced, suggesting that anaerobic respiration is taking place. And the RQ value can help us to determine the type of substrate or respiratory substrate used by the organism to carry out respiration. So in this table, we must remember the value. The RQ value when carbohydrates is used as a respiratory substrate, the value is 1.0, lipids 0.7, and protein 0.9. But when we carry out the experiment, we may not be able to get the exact value 1.0, 0.7, or 0.9. We may get in between. So if we have a value in between 0.7 to 0.9, then we can actually claim that it's a mixture of lipids and protein. If we get the value between 0.9 to 1.0, then we can claim that the respiratory substrate most likely will be a mixture of protein and carbohydrate. However, if the respiratory quotient show a value greater than 1, we can only conclude that it is an anaerobic respiration, but no way for us to know what kind of respiratory substrate is used by the organism. So now let us look at how we can calculate RQ value for carbohydrates and lipids based on the equation. So RQ value for different respiratory substrate can be determined using respiratory equation. Different respiratory substrate have distinct RQ value due to the variation in their chemical composition as well as the oxygen requirement during metabolism. So we have two examples here. Let us start with the calculating of the RQ value for carbohydrates. In this case, we use glucose as our example. So in the equation, C6H12O6 react with 6 molecules of oxygen, result in the production of 6 molecules of CO2 and 6 molecules of water is released. So how we calculate the RQ value? And we know that RQ value is calculated by dividing the volume of CO2 released per unit time over the volume of O2 consumed per unit time. So in this case, we do not need to convert it to volume. We can directly use the number of molecule. In order to oxidize one glucose molecule, we need 6 oxygen molecule and 6 CO2 molecule released. So based on this, the ratio will be 6 divided by 6, okay? The calculation of RQ value. So RQ gives us 1.0. So carbohydrate undergo complete aerobic respiration. Why? Because the value is not greater than 1.0, and the RQ value 1.0 indicates that the organism uses carbohydrate as the respiratory substrate. How about lipids? Example, in this case, we use uric acid as our example. So first of all, we start up with the equation. We need to balance the equation. So in this case, uric acid C17H33COOH reacted with 51/2 molecules of O2, result in the production of 18 molecules of CO2 and 17 molecules of water. So to calculate RQ value, we always divide the volume or the number of CO2 molecule produced in a respiration over the number of molecule of O2 used to oxidize the uric acid. So in this case, will be 18 divided by 51/2, where we get the RQ value of 0.7. So lipid require more oxygen for oxidation, which resulting in the RQ value less than 1. So 0.7 indicates that this is an aerobic respiration, and the respiratory substrate is lipid. With that, we have come to the end of this lesson. I hope you have found this lesson helpful. If you have any question, feel free to leave them in the comment section. See you in the next lesson. Have a great day.